Right. So, okay, now the next thing we need to understand is about the Coulomb. How do we measure charge? Right? How much? The unit of charge. Right? We call it the Coulomb. So let's see what is 1 Coulomb of charge. So we go back to the charge, the proton and the electron. A proton has a certain amount of positive charge and the electron has the same amount of negative charge. Right? So that when you put a proton and an electron together, they would neutralize. The net charge would be 0. Okay. So the Coulomb we can define, or we can think in terms of the proton. The amount of charge on a proton or electron is extremely small. So what we do is we take a large number of protons or electrons, and the total charge on that number of protons or electrons will be can be considered as 1 Coulomb. So how many protons should we take? The number happens to be 6.25 times 10 to the power 18. And if you can take that many protons, which is a huge number, it's 6 million, or we can say 6 million trillion protons. If you can put them together, if you can, right? Not that it's not possible to put so many protons together, but if you can imagine that we have done so, then the total charge on so many protons can be considered as 1 Coulomb. Right, so the same goes for electrons. If you take that many electrons, but this time the total charge would be minus 1 Coulomb, because electrons have negative charge. It's a different type of charge. Right. So so from this it follows that the charge on a single proton or a single electron is the 1 upon 6.25 times 10 to the power 18 coulombs, which works out to 1.6 10 to the power minus 19 coulomb. This is a very important number. This is denoted by the letter E. E is not electron. E is one of the fundamental constants in physics. Right? So the number E represents the amount of the quantity of charge on a proton or an electron. Right. So that is how we think the Coulomb. So, okay, what is the charge? What is the charge if we have, say, 2.5 times 10 to the power 15 protons? So the charge Q would be equal to 2.5 times 10 to the power 15 multiplied by 1.6 times 10 to the power minus 19, which works out to 4 times 10 to the power minus 4. That we can call it 0.4 millicoulomb. So many coulombs. So let me give you so we can formulate a very simple equation. Q equals NE, or N is equal to, okay, let's represent this as Q N times E. So if you want to find the number of charged particles when the charge on a body is given, then you can use this. N equals, you divide Q by E. So that is our first equation.